So hi, my name is Tony Lenz, and I am from MINDBODY, and today we're going to talk about Looper, the Android message queue, and some tips and tricks that you guys can apply when writing your Android apps. So real quick, can anyone tell me what's the very first program you guys learned to write? Hello World, right, exactly. And it looks like something like this. In Kotlin. I'm learning Kotlin, so it's really, if you guys want to present, write Kotlin code because it's really small and condensed and fits on slides. Pro tip. So this is function main, right? And as a student, you're like, here, write your main function and get going. Then you learn all the other stuff. You go through and then you write something that's less trivial rather than just printing the screen. You create this thing that has an indefinite loop. It goes on forever and ever. So this one is just ask for your name and ask if you have any nicknames, and just goes on and on and on. So you terminate, you give it an EOF, and it finishes, right? So any non-trivial application that a user interfaces with will have some sort of indefinite loop, right? Because as soon as it ends, main function, that's then a process, game over, you're done, right? So where you learn that, then you go on through the rest of your undergrad, even if you're self-taught, you start learning all these other core basics like object-oriented programming, data structures, yada, yada, yada. You start thinking, hey, I can code, right? You do assignments, trying to keep your head above water, and you build out a resume, right? And then you take a extracurricular elective. You're like, hey, I want to learn Android apps. So the very first thing they do, they download Android Studio. You download all the SDK. Takes you about an hour to download all, because you just check them all, right? And you just hit download. Source code, absolutely. All the emulators, you just pull them down. You're a student, you don't know any better, right? You open it up, new project. You just click next, next, next. Then you click the green button, run, and you get a Hello World application, right? You're like, that was easy. The problem is, it is so simple, it kind of doesn't allow you the opportunity to learn what's going on under the hood. Fresh new project created yesterday, 87 files were generated. So going up to that point, most students maybe had 10 files at the most. That was a big project for them, but you get 87 right off the bat. So you don't have no clue what's going on. And the only thing that's stubbed out, and I misspelled on create there, the only method you get is on create. So you create this false equivalency in your minds that main is on create, right? It's an implication that is not explicit, and it kind of screws with your mind a little bit. As we all know, that's not the same case, right? So I actually taught at Cal Poly, and one of my students was like, hey, where's main? I was like, that is a very good question. I don't know, right? And it launched into a discussion about what's the difference between an API and a framework. Because up until this point in school, you had main. You had your full control of your stack. Now on Android, you're writing against a framework. You don't call the code calls you, right? And that's a really big difference. It's a switch that you have to turn on your mind and realize that you're programming against a set of conventions. You're not making them up yourself, right? So, who's familiar with this? Come on, don't lie, right? We've all been there. And Android Studio, the tooling's amazing, right? It highlights your code in blue because it's like, it's probably you, right? It's probably you. And 99.9% of the time it is you, right? So you very obediently click that, you fix your pointer exception, and you move on your way, right? And who cares about the rest of this, right? I click the blue, we're good. So today I want to talk to you guys about what is the rest of that, right? What's calling your code, and why, and what can you do around that to increase your effectiveness as an Android programmer? So I'm going to just work up the stack. So, hey, we found main. There it is. Zygote init. So main function, public stack void main. Feels good, right? We're starting in a familiar place. So for those who don't know what a zygote is, here's a biology refresher. So it is a zygote is when a cell is formed by the union of two gametes. Gametes are basically half a cell, a sperm and an egg, right? They come together and they make a very unique organism. And the cool thing about that is that's the beginning of a new thing, and that new thing just divides and it just replicates itself. So the perfect name for this zygote process. So when the Android system boots up, it immediately spawns off a process, and it's all like warms up a bunch of libraries for you, a lot of the core APIs that you can call, does this warming up, and it's just gestating there, right? And then as soon as you launch your application, that zygote forks. And then you get a whole new Linux process, right? But you inherit all the stuff that process already done. So zygotonosis, fork, and that's what essentially is going on right here. You main, it spins up the zygote server. That server listens for calls to come in and tells it to fork and spawn a new process, right? So yeah, fork and run. Who cares about all the flags? We're just doing a flyover. So the next one is this activity thread. I found another main. It's another public static void main, but this isn't actually the entry of your process. They just did that as a kind of a marker. That's like, before this, it was all zygote stuff, and it was just doing system level things. Activity thread, Activity thread is like the start of your application, really. That's like the main of your application. And very much like the early programs you wrote, we need an infinite loop. And that's where this Looper.loop comes in, right? So it does a bunch of boring setup, and it loops. Because technically, as soon as it exits this main, you notice there's a throw new runtime exception, right? And what that does is, when you get to the end, your process is going to die. And this technically is not how the process wants to get shut down. There's other ways to do it, right? So the next thing up is this Looper.loop. There's our infinite loop. It's just basically sitting there and just churning. And it sits there processing messages off the message queue, right? Sorry, so yeah, it spins forever, has a message queue, it just pops it off and processes those messages. And dispatches them. So the looper, you actually never directly interact with the looper, right? The looper is just spinning there. It has a message queue, pull a message, do some work, right? Like orientation change, do that. Touch, do that. Draw, do that, right? So it just goes on and forever, right? How do you interact with that looper? You need a handler. So to interact with the looper, you just create a new handler. And the main responsibilities of these handlers is to schedule messages and runnables to be executed at some point in the future. So, for example, if you wanted to set up a timer rather than spawning a new thread and doing wait, then launch another event, you can get a handler and say, hey, post this runnable to do something in the future. So every second you can have time to have a timer execute some work, right? So you can post some work to do in the future on the main thread. Or if you're on some other background thread, you can very easily grab you get the main looper, grab a handler to that, and post stuff to the main thread. So if you're doing background work, you can get to the main thread that way, right? So looper, like I said previously, it spins forever. And the most important point is that's only processing one message at a time, right? So main thread, for those who don't know, threads can only execute instructions synchronously, right? One after the other. So as it's processing one message, you can't process any other message, right? So for example, when it does an onCreate, that looper is handling that message, dispatching to activity thread, and doing onCreate. If you spend a week in onCreate, there's tons of other messages like touches, other orientation changes, things that make it seem like your app's non-responsive. Because that looper is free to roam. Your application seems buttery smooth, right? And your handler, you can have n handlers for a looper, right? So by default, all views have a handler. So if you're ever in a position where you're creating a handler in a view, don't. You just say get handler. It's there. And the really cool thing too is that the main looper is statically referenced. So at any point in your code, you can just easily create a new handler to the main thread. So this is really helpful if you have some kind of like background thread that you want to post something to the main thread. You just create a new one of those. You don't need a reference to an activity, application context. You can just statically post things. So this other part, activity thread. So activity thread is, I'm going to just read off the documentation for you. This manages the execution of the main thread and application process, scheduling and executing activities, broadcasts, and other operations on it as the activity manager requests. So this is basically the handle from the system to your application for those the application components. And believe it or not, all the messages that get sent to the activity thread, you might see some awesome familiar ones like launch activity. The system sends a message and says, hey, launch this activity thread, then looks at your manifest, says, oh, hey, this handles the intent. We will grab that, instantiate it, create a new one, call on create, all that jazz. So these are where they're all statically defined. And the really cool thing, to come. I want to finish up the stack real quick. Instrumentation, this is a debug build, so it injects an instrumentation class in between, so you can very easily interact with that call. Then the create happens, then I try to touch a null text view, and that's how my stack trace got there. Hold on one second. Sorry. So quick debugging tip. You can just print out what the looper's going through. So the looper, you can just say, hey, set message logging. And from there, you can just print it out. You can actually even look at those and parse that string, and you can react to things based on that, right? So in looper, as it's going through the loop, it pulls a message off, and it's calling your logger right there, right? So that's the string that's going to get passed into that little Lambda expression up there. So I want to give you some cool tips. So if you rotate, this is the bane of existence, right? As soon as you're taught as a student, you're thinking on create to main, you set up your database connections, you set up all these things, right? And then you rotate, and then it's all gone, right? You're just like, well, that sucks. And you start trying to figure out how to use onSave instance state to save all your stuff. So you're parsing everything to JSON, you're shuffling it as a string, you're putting things in preferences, just to save this transient state that you don't want to lose, right? Then you read, you're like, oh, you can use the retain fragment. So when you rotate, the retain fragment is there forever. And you can just put data on that retain fragment, get that retain fragment from the fragment manager, and continue on your way. So one day I was just sick and tired of that, right? Because it's just a lot of ceremony. You have to go there, you have to create the fragment, you have to ask the fragment manager if it's there, you have to interface with that fragment. It's like this kind of weird wrapper, right? I was like, how is fragment manager doing this? There's nothing that the app compat support library does that I can't do, right? Because it's just a library. There's no specific framework code that it can't get a hold of. And then digging through, looking at it, I found out that fragment manager is relying on this method called onRetain custom non-configuration instance. So for those who are not familiar with this, who's heard of this method before? Cool. So the rest of you, mind gonna be blown. So this is really cool. Before Honeycomb, there's this method called onRetain non-configuration instance, and that allowed you to pass an arbitrary object from one activity to the next activity, right? So as this activity is getting destroyed and this one's getting created, you can just pass an arbitrary object between them. So when Honeycomb came about, fragments came into play. So they actually deprecated this method so they could use it for fragments. And then the advice was to don't use this, use fragments, use retained fragments. And the support library actually relied on that method to do the support fragments. And they gave you a handy dandy on retained custom non-configuration instance, right? Because they had to rename it something or else it would collide with the activity. So the custom one is for support library. The other one is the framework. And fun fact, on retained non-configuration instance was deprecated, I think in NuGet. So it was deprecated, it was outside, and then they brought it back in. So this is very important. And this is the key where I think it gets most of its usefulness. Because I was always afraid, let's say you're running an async task, right? And you're doing some background work in that doing background. You're going, and the results get delivered. I was afraid that if you were to pass that along to the next one, there's a moment, right? There's a moment in time. If the results get delivered, you might miss it, right? You're like, okay, it rotates, it finishes right then, the new activity is not created, I just lose my results, right? Are you following? Okay. So the benefit of this is it gives a good example that there's a guarantee no message handling during the switch to the next activity, simplifies these active objects. So what that means is when the configuration change happens, the new activity is going to be created and onCreate is going to be called in that same message. So there's no other message that the looper is going to process until that's complete. So you're guaranteed that if you post a message for those results, which what async task does, right? On post execute, actually post the message to the main thread, right? So even if that result, that background work finishes before you, background work finishes before the new activity is created, the results are just posted to the main thread. So when you on create look at it, the results will be delivered after that new activity has been created. Does that make sense? And hopefully this will illustrate a little bit better. So I went ahead and logged what the looper was doing. And you can see here, dispatch the handler, activity thread H, that was this handy guy, right? That's a private class and activity thread. And it's some jargon, that's activity thread. The hex code there is referencing that. I think it's just a 2-string on that, so that's the int code. And 118. 118 is that message. So if we look down on configuration change. So I had rotated it. A message was dispatched saying, hey, a rotation had occurred. 118, right? That was processed in activity thread, did some work, then it posted another message right after it. What that message was 126. 126 was saying, relaunch the activity, right down there at the bottom. So it said relaunch the activity, and what that looks like is, so it's dispatching, relaunch activity, it does the teardown of the old activity, and on retained custom non-configuration instance gets called, it holds onto that object, it creates a new activity for you, right, and then sets it on that new activity, all in that same message. So if you had some background work, if you had posted that background work to this thread, it would be dispatched after all that had occurred. Does it make sense? Like, this is a big deal. And it was just like mind-blowing. So, okay. So please don't blindly post to your handler. How many of you have come across this exception? Called from the wrong thread exception. Right? You did some background work. You're like, hey, I want to set this result on my view. And it said, can't do that. You're on a background thread. You're like, no problem. Run on UI thread or handler.post. The problem with that is you don't know when that background thread completed, right? So it could have been completed in a non-opportune time, right? So you could actually be, this happens a lot too with fragments. You can post it, and let's say the user pressed home and put your application in the background, onStop was called, right? And for those who don't know, you can't commit fragment transactions after onStop has been called, right? Because it uses the save instance state to store the fragment stack and the state of the fragments. So most of you will just say, hey, commit with loss, right? You're like, that's fine. That's not the solution. The problem was that you're just blindly calling post, right? That you didn't know when you're going to be scheduled to run this. You just were trying to avoid this exception, right? So you're not guaranteed the UI will be around either, right? So you could say post, go to touch it. You update that view because you have a reference to it, but that view has been trashed and you have a new activity, for instance. What I do suggest is that instead of run on UI thread or using post, that you can just straight up create your own message queue, right? You can kind of use the underlying principle that Android uses to help manage when you want things run. So for instance, instead of run on UI thread, you can post this to a custom built message queue, right? It could just literally be a queue of custom messages, whatever you want to structure it as a callback, right? And you can register and unregister that callback based on the lifecycle, right? And then on orientation change, you just dump that event queue and process it, and you just manage it on your own time, right? The benefit of this is that you can avoid those nasty committing after on save instance state has happened, or just possibly updating the view that is no longer alive, right? And that's essentially what a lot of architecture components are. So if after this talk, I highly recommend go and look to see what they're doing, and you can dive deeper into that. And that's essentially what they're doing. They're queuing up stuff, and they will only deliver it to you between on start and on stop when the application is visible, right? Which is fantastic. But I just want to empower you. You can do it your own way too. So there's more. So here's another stack trace. Instead here, I want to focus on choreographer. Does anyone know what the choreographer sound familiar to any of you? Okay. So for those who aren't familiar, choreographer, the main point of choreographer is to receive time pulses from vsync, right? So you have the display refreshes at a given interval, and at a certain time it says, hey, it's time to update the display. So the choreographer is the one receiving these updates and wants to dispatch them to do things like animations and schedule work to do things that are going to impact the next frame that's going to be drawn, right? So you technically usually don't interact with choreographer. It's a higher level abstraction. The animation framework is what you should be using, or the view hierarchy directly. So this is in the same way I just posted activity thread.h. This is the handler and choreographer. So it handles the do frame. Do frame, going back to this, you can see it says do frame. It dispatches more stuff, and it's basically telling the view to draw. So at the very top, this message says, hey, we got a vsync. We need to update the display, do an on draw, right? Here's a really neat thing. Who's used Android Databinding? Okay. It's pretty fantastic. So Igor and George Mount were the ones working on it, and they did a really cool thing. So you can actually update your view models on a background thread, and it gets reflected on the UI thread. There's no posting, there's no run on UI thread. They manage all that stuff for you. But the really neat thing is, instead of dispatching stuff all the time, let's say you had a property that was changing every millisecond, right? So instead of dispatching that 15, 16 times and doing that work 15 or 16 times, when the last time is the only one that's going to be seen, because that's when the draw actually occurs, it batches them. And it uses choreographer. It puts a frame callback on choreographer to actually execute those bindings. So you can actually queue up all the stuff. You can set all these properties, and those properties aren't actually set on the view until the system's ready to draw, right? It saves tons of work, and it frees you up from not worrying to have to how often should I set this variable? It doesn't try to do layouts. It doesn't do all these things. It only will do it on every frame, right? Which is really, really useful. The next one is the input framework. So when you touch, sorry, I thought I had another slide. So not only does all this reside in Java, there's also a native message queue. Who's done JNI or native coding for Android? Right? You can still post the message queue natively, and the message queue that's running in the VM will pull for those messages and do those. Example is when you touch the screen. This used to be the job of the choreographer, and then they've kind of pulled that out, and now it will dispatch to the input event receiver. So, and then from there, it dispatches to root view impl. So root view impl, this is an implementation detail. Again, it's kind of like a choreographer. It does nothing that you can't do yourself, but you shouldn't be really looking into it. It's basically the interface between the window manager and the views. So this is everything's going to basically pipe through view root impl, such as draws, touches, layouts, and all that jazz. So the main takeaways, I want to I flew through this. The main takeaway is stay off the main thread. So by staying off the main thread, it allows the more messages to be processed, allows more work to be done seamlessly, right? And a big part of doing that too is trying not to pre-optimize things. For example, I had a friend who was doing stuff in OnDraw, and he would refuse to do method calls because he's like, method calls have inherent cost. And that's time away from the drawing, right? I was like, yeah, that's true, but you also have 16 nested layouts, right? Which it's like you're optimizing the wrong place. So realizing too, when you're designing your layout, the more complex, the more time that you spent, the layout pass is also affecting performance. That layout pass is happening on the main thread. So if you can stay off the main thread, however you can, just not whether it's not serializing code or doing actual like business logic, try to just back off of that and do things in the background and update the UI accordingly. Be careful when you post, and batch work when possible. Cool. Yeah, sorry it was so quick, but do you guys have any questions, thoughts, or concerns? No? I highly recommend you guys check out the on-retained non-configuration instance. Commonsware, Mark Murphy. Do you know if Mark Murphy's here? That'd be great. I'd love to meet him. He did a great job of demonstrating this thing in that sample project. And you can just try move around and break it. It's solid as a rock. So give that a shot. Cool. Thanks.